This is Algebra 2, Unit 6 on rational functions. This is Lesson 2, simplifying rational expressions. What we're going to do is look at basically a giant fraction and see how we can factor it and reduce it to something a little bit simpler. And then we're going to look at something called excluded values. So we're going to tap into the old factoring lessons that we've done. I know that was a favorite of everybody's. Just kidding. Anyway, so we're going to look at an example where we have x squared minus 10x plus 21 divided by x squared minus 4x minus 21. Now, if you notice, there's a trinomial in the numerator and a trinomial in the denominator, and we need to factor both numerator and denominator. If we have anything that is the same in the top and in the bottom, we can cancel it out. And the way that we factor trinomials is we generally use a t-chart. So we're going to do a t-chart for both parts. And so the t-chart, remember, we use b, and then that's going to go right here, and then we're going to use a times c, and that's going to go right here. So in this case, b is negative 10, a is 1, c is 21. We multiply that together, which is still just going to be 21. And so we look to 21 and try to think of everything we can to multiply to get 21. We know 1 times 21. We know 3 times 7. Well, which pair would give you a negative 10 if you added them or subtracted them? Well, 3 plus 7 gives you a positive 10. And so when that happens, you know that you need to make both numbers negative. So that's going to be negative 3 and negative 7. So that'll give you a negative 10. Also, negative 3 times negative 7 is going to give you positive 21. So I know I can factor the top of this problem into x minus 3 times x minus 7. Okay, we're going to do the same thing with the trinomial in the denominator. So again, another t-chart. This time we're going to use negative 4 because that's b. And again, a is 1 and c is negative 21. So 1 times negative 21 is negative 21. So what we're going to do here is, again, we know 1 times 21, but one of those numbers has to be negative because 21 is negative up here. And the trick is, whichever number is bigger is always going to follow this sign. So if this is negative, that means 21 has to be negative right here. Well, we know that's not going to give you a negative 4 if you add or subtract them. So let's try 3 and 7. 7's bigger, it's going to follow the sign of negative 4. So if we add 3 and negative 7, we do get negative 4. So we know that when we factor this one, it's going to be x plus 3, because 3 is positive, but it's also going to be x minus 7. So at this point, do you see how you have the same thing in the numerator that you do in the denominator? Now I want to pause here for a minute. We are going to cancel those out simply because they're in parentheses and they're being multiplied. This is all one thing. This is all one thing. And this is being multiplied by x plus 3. This is being multiplied by x minus 3. So as long as something is being multiplied, you can cancel out the entire part of that problem. If we go back to the original problem, people want to cancel out like the x squareds and they want to cancel out the 21s. The only problem with that is x squared in the top is being subtracted and then you're adding 21. Down here it's being subtracted, or actually it's subtracting from x squared like up here, and 21 is negative. There's some adding or subtracting going on with x squared and with the 21s. Whereas here, this is all being multiplied. You can cancel when something is being multiplied. You cannot cancel it individually when it's being added or subtracted. So that's why you can't cancel out the x squareds or reduce the 21s. But at this point we can. We're going to cross out x minus 7 over x minus 7. But before we do that, we also have to look at what makes this denominator 0. These are called excluded values. Now, excluded is the opposite of included. If you are included in something, then that means that you are a part of it, okay? Excluded means it cannot be a part of it. So there is a number that I could substitute in for x right here. That's going to make this 0. So basically all we're doing is taking each little piece that we've got when we factored it and we're making it equal to 0. And then you just solve it. So we're going to subtract 3 from both sides. That means x is equal to -3. Well, you could probably figure that out just by looking at it. What number could I put in for x that's going to make this 3 become a 0? And that's going to be -3. Sometimes it's extremely obvious, sometimes it's not. So that's why I'm showing you this part. But you have to do the same thing with the second set of parentheses. So I'm going to add 7. Remember, we set it equal to 0 and solve it. So now I'm going to get +7. So my excluded values are -3 and +7. We're going to make that part of the answer when we write the final answer. So now I'm going to go up here. I'm going to cancel out these. They're gone. So now my final answer is what I have left. And that's going to be x -3 over x plus 3. But then we've got to include the excluded values. So we're going to put x is not equal to -3 and 7. And that is going to be your final answer for that problem. I'm going to do one more example and then you should be good to go with your assignment. The second example has 2x squared plus x on the top in the numerator, and then on the bottom it's 3x to the third plus 7x to the second plus 3x. Now this looks scary. Now I'm going to remind you, you cannot cancel out x squareds with x squareds or x's with x's if they're being added or subtracted. Now if they were just being multiplied and nothing else, then you could, but we can't here. The top is a binomial, and I noticed that there's an x in both of those. So what I'm going to do for the top is I'm going to do a greatest common factor. I'm going to factor it that way. But I also noticed that there's an x in all 3 terms in the bottom. So I'm going to actually do that for the bottom as well. Now the bottom looks like I could possibly go further. We'll wait and see if we can when we get to that point. So let's look at the top. Let's take out that x. Now remember, it doesn't just disappear. It stays in front of the parentheses. And all you're doing is you're basically dividing 2x squared divided by x. That's going to be 2x. Now watch this. X divided by x is 1. So there's the numerator factored out. Again, we're going to take an x out of the denominator because there's an x in every term. And that's the only thing that all 3 of those terms have in common. So we take an x out. That's going to be 3x to the second power plus 7x plus 3, because remember, when you take 7x squared and divide it by x, you're basically taking one of these x's away, which is going to leave you just 7x. And when you divide by x with 3x, you're basically getting rid of that x, and so that just leaves you 3. So now we see we have an x on the top and an x on the bottom, and it is being multiplied. So you can cancel that out, but now remember, we have to talk about our excluded values. So this is a little different than before. I can set that x equal to 0, okay? So that's definitely going to be one of your excluded values. When we look at this part, it looks like it could be factored, kind of like we did in the first problem. So I'm going to try and do a factoring of this. And let me pull this back over. So if we look at b is 7. And then we're going to do a times c. Well, 3 times 3 is 9. Okay, now we've run into a problem because look, I can do 1 times 9 and I can do 3 times 3. But if I add or subtract 1 and 9, it's not going to give me 7. If I add or subtract 3, it's still not going to give me 7. Nothing works. that means that this cannot be factored anymore. So we're just going to stick with our excluded value of 0, and then we're going to go ahead and reduce by canceling out these x's, and so your answer is going to be 2x plus 1 over 3x squared plus 7x plus 3, and then x cannot be equal to 0. That's telling you that it's excluded right there. And there is your answer for the second problem. Now, your assignment is going to look like this, and these are a little bit easier. I wanted to show you number 1, simply because there's just a 24. There's nothing that you can factor 24 into like you can in the top here, so it's going to stay 24. And as long as your denominator is just one number and no variable, you will not have any excluded values. So there's no excluded values for number 1. But if you look at these other ones, like this one, yes, you're going to have some. You're going to have some here. You're going to have some here and here. That's what you're looking for. Some of these problems, you're going to use T-charts, like you're going to use a T-chart here to factor. But here, you're just going to take out a greatest common factor. Here, you're going to use a T-chart. Again, greatest common factor and T-chart. So work on these and let me know if you have any questions when you start.